Hello everyone, today we're going to be looking at the process of adding and subtracting algebraic fractions and then look at the simplification of this as well. Now before we go into algebraic fractions, I think it's just important to have a grip on adding and subtracting fractions normally and then applying that to the algebraic questions. So normally whenever we add or subtract fractions we need a common denominator. Now, the easiest way we can do this is by simply multiplying the denominators together. If we multiply 4 with 3, we get a denominator of 12. But whatever you do to the denominator, so we times this by 3, you have to do to the numerator to keep it as an equivalent fraction. So this becomes 3 over 12. Over here, we multiply the numerator and denominator here by 4. We get plus 4 over 12. And then we simply add the numerators together, giving us a value of 7 over 12. Now, the scenario on the right-hand side, we can do the same thing and obtain a common denominator of 50 by multiplying the 5 with the 10. But what some people may identify is that if I simply multiply the 5 by 2 and times the top by 2 as well, I'm going to get a denominator of 10, i.e. the lowest common denominator. And this is very important for when we come to some of our later questions. 2 over 10 minus 1 over 10. For this one, I'm actually going to put them both over the same denominator and subtract first like this, 2 minus 1. And then when we subtract the 2 minus 1 over 10, we end up with 1/10. So very, very simple here was just to obtain our common denominator and then add and subtract the numerators. So I'm now going to bring this to our first two examples, which are over here. 3a plus 3 over a plus 4 over 5a is our example on the left-hand side. Now, the reason why I'm keeping this example here present is because if you look at the denominators in this case, we could multiply through them both together to get 5a squared. But as I said, some people may notice that if I multiply this a by 5, I'm going to get the same 5a as I do here. So if I do that to the the denominator, I have to also do it to the numerator. And that then gives me a value of 15 over 5a plus 4 over 5a. I don't have to do anything to the right-hand side because it's already got the same denominator. I can now add the two numerators together. On the top, 15 plus 4 all over 5a, and that gives me a final value of 19 over 5a. And that's as simplified as we can get. We can see there's nothing that can be cancelled out from the numerator and denominator. Now, if we bring this to the example on the right-hand side, a little bit different over here. 4 over x minus 1 minus 2 over x minus 2. Now, we can see here this time round, there isn't a way that I can multiply this to make this. So in this sense, it's like we've got two denominators over here, 4 and 3. And to get the common denominator, we just simply multiply the 4 with the 3. However, something to take into consideration is that when you have a denominator like this, which is in algebraic form, it is as if all of this is inside of a bracket. So the common denominator I'm going to get in this case is going to be x minus 1 times x minus 2. And actually, it's better to keep this in brackets. It's better not to expand these out. So over here, x minus 1 over x minus 2, x minus 1 over x minus 2. And we can see that on the left-hand side, I have multiplied the denominator over here. This has been multiplied by x minus 2. So I've got to multiply the numerator here also by x minus 2. So that gives me 4x minus 2. Then on the right-hand side, I've multiplied the denominator by x minus 1. So I'm going to get the same thing on the right hand side, minus 2 brackets x minus 1. Now you saw here a moment ago that I combined the denominator together here, and this is very important for this question. When I combine the denominator in this question, the numerator, I get 4 brackets x minus 2 minus 2 brackets x minus 1. And then all of that is over x minus 1, close bracket, x minus 2. Now for this step, I need to expand the brackets on the numerator and then simplify it down. So I'm going to do that over here. Just looking underneath to continue on with a bit of extra space. So we have over here, if we are expanding the numerator here through, we will end up with 4x minus 8 minus 2x, and then minus 2 times minus 1 is plus 2, all over x minus 1 and x minus 2. And then it's just a matter of tidying up the numerator. We can see over here we have 4x minus 2x, that leaves us with 2x, and then minus 8 plus 2 gives us a value of minus 6, all divided by x minus 1 and x minus 2. Now, as a last step here, you can also factorize out the bottom, the numerator on the final line. There is a common factor of 2 that can come out. So just to finish that up, if we take out a factor of 2, we end up with 2 brackets x minus 3 over x minus 1 and x minus 2. So going back from the beginning, right back to the top, we first multiplied through the denominators to make them the same and did the same to the numerator as we did to the denominator. We then put it over one fraction and then expanded our brackets, simplified down, and then finally factorized. If there'd been an x minus 3 on the bottom as well, we actually could have cancelled that out. Now I'm going to build this onto one final example, which is going to incorporate a quadratic, which we will see over here. So over here we have this quadratic over here, 3x over x squared plus 3x plus 2 minus 2 over x plus 2. Now this is kind of a combination of these two scenarios over here, but whenever you have a quadratic, it's always best to try and factorize it if possible. So if we look to factorize the quadratic on the left hand side, we need two numbers that multiply to make 2 and add to make 3. Well, that is 1 and 2. So therefore, if I factorize the quadratic on the left hand side, I'm going to get 3x divided by x plus 1 and x plus 2 minus 2 over x plus 2. Now we'll notice over here that x plus 2 is a common factor on the bottom. So just over here, as we did 5a and a, we times this by 5 to make it consistent. We are going to multiply this denominator by x plus 1 to make the denominators the same. So if I multiply this by x plus 1, the denominator, I have to multiply the numerator by x plus 1. That will give me 3x minus 2 brackets x plus 1 all over x plus 1, x plus 2, and again all over x plus 1 and x plus 2. So that was by multiplying the numerator and denominator by this value of x plus 1. We can now put it all over one fraction. So if we put this all over one fraction, we get 3x minus 2x plus 1 all over x plus 1 and x plus 2. And if we now expand the bracket on the top, we get 3x minus 2x minus 2 over x plus 1 and x plus 2. And to finish that up, we just need to tidy up the top. And by doing so, we are just simplifying what's over here. 3x minus 2x is x. We've just got this minus 2 over here, all divided by x plus 1 times by x plus 2. We don't need to expand the brackets on the bottom. We are more than happy to leave it like that. It looks nicer, it looks more simplified. If you want to also put a pair of brackets on the top as well, you can do. But we still followed the same principle here. We first factorized our quadratic. We then obtained our common denominator. We multiplied the numerator and denominator by the same value. We then put it all over one fraction, expanded our bracket, and simplified it down. I hope that's made sense. That's the full process for this topic. If it hasn't made sense, please let me know below, or please let me know via a message. Thank you.